Lots of activity at the S-Range test facility in Kiruna, Sweden last June as the ExoMars team prepared for important parachute drop tests. The team was testing both the stratospheric first stage supersonic parachute and the second main stage subsonic parachute of the ExoMars descent vehicle, both of which are crucial for ExoMars to make a successful landing on the Martian surface on June the 10th, 2023. Landing on Mars is always a challenging endeavour, and all possible parameters are taken into account.
Going on Mars is quite an adventure, and it took us quite some time to select the most appropriate landing site on Mars. It took us 5 years actually to find a place that would be both scientifically interesting, where we potentially could find some traces of past life, and also it had to be a safe area for landing. One of the complexity of landing on Mars is related to the thin atmosphere, and therefore, in order to land safely and have all the deployment sequence fitting into the altitude that we have available for braking, we had to select a landing site that has an elevation rather low compared to the average elevation of the surface of Mars. We have selected the Oxia Planum landing site that is at an elevation of minus 2.8 kilometers. With that gives us more space for braking through the atmosphere in the sequence after the aerodynamic braking, the parachute braking, and the propulsion system braking before achieving a soft touchdown on the surface of Mars.
To simulate the extraction forces pulling on the descent vehicle and on the parachutes during a landing on Mars, the drop test vehicle is lifted to an altitude of 29 kilometers with a giant stratospheric balloon. Once released, a pilot chute is deployed to pull out the parachute. Although both parachutes were tested separately during the drop test, on Mars they will need to be deployed in succession. The first parachute will need to slow down the descent vehicle from Mach 2 down to Mach 0.6 in 20 seconds, after which the second main stage parachute will deploy to slow down the vehicle even more for 2 minutes. Then the heat shield will be discarded and the landing platform will be released for a propulsive braking phase. The ExoMars launch window is only 12 days, and it opens on the 20th of September 2022. Then the mission will be launched on top of a Proton-M rocket from the Baikonur Cosmodrome.
So the ExoMars spacecraft composite is composed of a carrier module, a descent module, a landing platform, and the rover module. The carrier module will transport the descent module towards Mars and is responsible for making all the trajectory correction maneuvers during the trip. This trip will last 8.5 months. Upon arrival towards Mars, we will separate the carrier module from the descent module about half an hour before the entry into the atmosphere.
The mission contains 2 scientific elements designed to address the long-standing question whether life ever existed on Mars. First, there is the Russian-built Kazachok surface platform, which will perform measurements of the environment and geophysics on the surface of Mars. Secondly, there is the European Mars Rover Rosalind Franklin, which has 2 sets of cameras that provide stereo vision to avoid rocks and other obstacles. Each of its flexible metallic wheels can be driven independently, and when the wheels get stuck, it can revert to wheel walking to get back on solid terrain. The rover can navigate independently and travel up to 100 meters per Martian day. Its 2-meter drill can extract samples for analysis in the onboard laboratory to search for clues of life.
With the surface of Mars being irradiated by the solar radiations, we believe that finding life on the surface is probably very, very difficult. But we've calculated that down to a depth of 1.5 meters, we could have chances to find traces of this life that has not been actually burned by the radiations. So that's why on board the ExoMars rover, Rosalind Franklin, we have installed this drill that will be able to drill into the surface of Mars down to a depth of 2 meters. That's the deepest depth at which one has ever drilled on Mars. So we will do this drilling and try to extract some samples for analysis on board.
ExoMars is an essential next step for ESA in the field of robotic space exploration, as it will provide key technology on landing, moving around and sample collection on Mars and other planets. Later, a Mars sample return mission will even bring samples back to Earth for further analysis. By visiting our closest neighbour, we will also learn more about our own solar system and the habitability potential of other planets.